Given some h sub z, using partial fraction expansion, find h sub n. Perfect. So let's start off with the first thing we want to do is we want to kind of clean this up. And the first thing we want to do is multiply the top and the bottom by 6. So if I do that, so multiply this by 6 over 6, I'm going to get 12 minus 12z to the negative 1, all divided by 1 minus 5z to the negative 1, plus 1z to the negative 2. Now, I need to put this into positive powers of z. To do that, I'm going to put top and the bottom by z squared, because that's the largest one we have. So, I am going to get 12z squared minus 12z all over z. I'm sorry, this should be a 6, by the way. I forgot to multiply that into the 1. Sorry. So this would be 6z squared minus 5z plus 1. Now, the whole point of this was to factor the bottom. So we need to figure out what the bottom is. So to do that, we're going to use a quadratic formula. So we have negative 5 plus or minus the square root of b squared, which is 25, because 5 squared is 25, minus 4, 6, 1, all over 2 times 6. In other words, negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's clean this up. I'm going to get 5 plus or minus the square root of 25 minus 24 all over 12. Then I get 5 plus or minus 1 all over 12. So my answers are going to be 1/2 and 1/3. I'm sorry, 1/3. Perfect. Let's plug those values in. So what I get is these are my answers, and I can plug them in. I'm so sorry. 12z squared minus 12z all over z minus 1/2 z plus or minus 1/2. Well, what exactly did we solve for? What is this denominator down here? Let's solve for it, and we're going to get z squared, this is a 1/3 by the way, minus 5 divided by 6z minus a 1/6. This answer here looks super similar because it is just this down here in positive z terms. So we don't have to worry about this up here. This value is the original value of 2z squared of 2z squared minus, what is it, minus 2? Yes, minus 2z. So I hope you see how I did that. So this isn't actually what's up top. This is what's up top, because when we factor this, we get our original function in positive powers of z. All that ended up happening was we multiplied the 6 in to clean it up. And multiply the 6 on the top to clean it up. So you need to realize that for this problem is that what you're not actually solving for is with this top. You're solving for with the original top. So the next thing that we need to do is get this back into negative powers of z. So to do that, I'm actually going to stay into the form of 2z squared minus z all over z minus 1/3 z minus 1/2. I'm going to stay in this form. What do I need to do now? I need to multiply the top and the bottom by z to the negative 2 all over z to the negative 1 times z to the negative 1. This is the same thing as z to the negative 2, but this will go into each of these terms. So if I had 3, 4, 5, 6 terms, I'd break that up into that many z to the power of negative values. So let's go ahead and do that. So I'm going to get 2 times 1 minus z to the negative 1 all over 1 minus 1/3 z to the negative 1 minus 1/2 z to the negative 1. And let me erase this. I worked on it a little earlier to make sure I didn't mess up. Okay, now the next thing I need to do, which is super important, is I have 2 terms here. So I need it to equal a over each of these terms. So a over 1 minus 1/3 z to the negative 1 plus b over 1 minus 1/2 z to the negative 1. Now, it doesn't really matter which one's A, which one's B. I'm going to be honest with you. It doesn't matter. You could do it in either fashion that you want because they're both going to give you the same answers. Okay. The next thing we need to consider is this is what Tekamp has been trying to explain by, I don't know if he got it across properly to most of you, so I'm going to try to break this down extremely simply for you. Each of these terms has a value if z to the power of negative 1 equals 3 and z to the power of negative 1 equals 2, this here is 0 and this whole thing here is 0. Now you're asking, well, why is that important? It's important because let's multiply the top, the A, by, or multiply everything, all the way across by 1 minus 1/3 z to the negative 1. So I'm going to show you what that means. So I'm going to say 2, 1 minus z to the negative 1. I just want to make sure I got that correct. I'm sorry. Now you will realize, obviously, if I multiply everything by 1 minus 1/3 z to the negative 1, that this will cancel out, this will cancel out, and there will be a 1 minus 1/3 z to the negative 1 right over here attached to the b. So let's go ahead and do that. So I'm still going to have on the bottom 1 minus 1/2 z to the negative 1 equals a plus b 1 minus 1/3 z to the negative 1 all over 1 minus 1/2 z to the negative 1. If I allow for this, allow b to equal, sorry, not b, I'm so sorry. Let me clean that up. Allow z to the negative 1 to equal 3. What happens? This here goes to 0, and all that I have left is 2. 1 minus 3 all over 1 minus 1/2 times 3. And I have that equals a. And that's the whole point of this. So let me show you. I'm going to have 2, 1 minus 3 divided by 1 minus 1/2 times 3 equals a. Because the b goes away. So then I have 2 times negative 3 all over, and this is going to be 2 over 2 minus 3 over 2. So that's going to equal negative, what is that, negative 6, all divided by, and that should be a negative 1/2. So this should equal 12, if I'm not mistaken. No, I'm so sorry. 1 minus 3 is not negative 3. 1 minus 3, let me clean that up. I'm so sorry. I hope you saw my little mistake there. Okay, 1 minus 3 is negative 2 all over 2 over 2 minus 3 over 2. Sorry for my mistake. That equals A. So I can say A equals negative 4 all divided by negative 1/2, which equals 8. So A equals 8. Now we need to solve for B using the same technique, but instead we're going to allow z to the power of negative 1 to equal 2. So I'm going to distribute this whole thing, the 1 minus 1/2 z to the negative 1, into each of these terms. So I'm going to say, I'm going to have 2, 1 minus z to the negative 1 all over. Now remember, I multiplied by the 1 minus 1/2 z to the negative 1. So all I have is 1 minus 1/3 z to the negative 1 equals A times, 1 minus 1/2 z to the negative 1 all over 1 minus 1/3 z to the negative 1 plus B. Because remember, if you look at the B up here, the B has a 1 minus 1/2 z to the negative 1. So that cancels out with that, and you just have a 1. Perfect. Now again, I'm going to allow z to the negative 1 to equal 2. If I do that, this whole thing goes to 0. Because this will be 1 minus 1, which is 0. 0 divided by anything is 0. So let's go ahead and plug that in. I get 2. 1 minus 2 all divided by 1 minus 2/3. I believe that should be left. Let me double check that, make sure that that was what's up. Yep. 2/3 equals B. Okay, so I can write this as 2 times negative 1 all divided by, this is 3/3 minus 2/3 equals B. We're going to bring it down. I'm going to get negative 2 all divided by 1/3, which is the same thing as negative 2 times 3 divided by 1, because we take the reciprocal, copy dot flip, equals B. Therefore, B equals negative 6. So all I'm going to redo now is I'm going to rewrite this entire equation, but I'm going to plug in A. So A is going to equal 8. I believe it was 8. Yep. And B is going to equal negative 6. So I'm going to go ahead and do that really quickly. So I'm going to have 8. So I'm going to have 8 divided by... I'm sorry, I'm really slow at this because I'll make little mistakes. So I have to go step by step so I don't mess it up. I'm sorry. 1 minus 1/3 z to the negative 1. 1 minus 1/3 z to the negative 1 minus 6 divided by 1 minus 1/2 z to the negative 1. I want to double check that really quickly. Make sure I didn't mess that up. A is 8 and A is attached to this one, so 1/3. Negative 6. Perfect. Okay. Now this is equal to h of z. Now the only thing that's left, and I don't know, if you want me to walk you through this, please let me know. I can make another video about this. All you are now doing is you're looking at, I'm going to go to my final, so this is it. Go down to here. Here is where you have all the transforms. So if I looked at it, this is 6 all over 1 minus 1/2 z to the negative 1. Well, what looks similar to that? I don't have a z up top, so I'm going to put this closer. I'll keep messing this up. So it can't be this. It has to be this one here. You'll pull the 6 out front, and so you have 1 minus 1/2. So that's that 1/2, correct? You have that 1/2. So I'm going to have, I'll just do this one so you can see exactly what I'm talking about. So I'm going to pull out that negative 6 times 1 1/2 z to the negative 1. this is equal to -6. My a is my 1/2. So I believe it was a to the power of n. Yep, a to the power of n. So 1/2 to the power of n. And then I have u to the power of n. So this will be times u to the power of n. Now, if I'm not mistaken, because this z is to the -1, I believe this should be n minus 1, n minus 1. Let me double check that really quickly. Nope, I was wrong. So just leave this as n. And that's all you have to do. That's why. Because it's z to the -1, remember, that's z to the -1. That's why it's just n. So you have -6, 1/2 n, u to the n. Next thing for the next one, you will have 8, 1/3 to the n, u to the n. So you just combine this and say, what was it, h sub n? I want to double check really quickly. I don't want to do something wrong. Yep, h sub n. So h of n equals, I'm going to have 8, 1/3 to the n, u to the n, minus 6, 1/2 to the n, u to the n. So this last part, it's just going to depend on the problem. You need to go through and look at your transformation chart, and that will tell you exactly what to do. If you have any questions, please leave those in the comments. I am more than happy to answer any of them. Thank you for watching.